A very pleasant good morning to all and welcome to 5 days faculty development program on innovative research and development trends in electronics and communication engineering. I, Dr. Asta Sharma, on behalf of EC Department, welcomes Galaxy of Intellectuals, Your Excellency, Chief Guest of the Day, respected Director Sir, HOD Sir, HODs of other department, faculty members, and dear participants. Thank you for taking time out and being here today. We are very grateful to have Dr. Brahmjit Singh sir as our chief guest of today. The agenda of today's meeting is 5G wireless networks and its adaptation in India. Before that, I would like to give a brief introduction about our department so that we let you know that what we are and who we are. So just sharing my screen. Is my screen visible?
Yes.
Thank you. So, before starting about the department, I would like to briefly introduce our institute, that is GL Bajaj Institute of Technology and Management, which is one of the prestigious institutions under the GL Bajaj group of institutions. It is one of Uttar Pradesh best engineering and management college and is known for providing its student quality education and great placement opportunities. It is approved by AICT, Ministry of HRD, Government of India, and is affiliated to AKTU University. The Department of ECE visions to become a department of repute and prepare globally competent and socially responsible professionals with holistic knowledge and technical skills under the mentorship of Dr. Satyendra Sharma, HOD of Department of Electronics and Communication Engineering. We provide undergraduate course that is BTech, which is approved by AICT, and our department is NBA accredited. We have always exerted the best of its efforts to meet the objective of achieving technical excellence in the areas of electronics and communication engineering. These are some of our highlights of the department, where we can see the first commendable thing is ever increasing seats of EC department. From 2005, when the institute was started, it had 60 seats and now it has grown to 180 seats. We are always providing number one rank in Uttar Pradesh, and the best thing is that in the first semester result, this session only 2021, we have number one ranking in the result, 90.39%. Also, about the research groups which are here in EC, we are always being engaged in producing quality publications and doing quality research. We have 5 research groups here, and our faculties are so dedicated that till so far they are actively engaged and are filing patents. 20 plus patents have been filed and published. Our students are very dexterous. We have best brains with us, and the students' projects which are awarded and granted are approximately 15 lakhs. Also, we have 11 laboratories and 6 advanced laboratories, and our faculties and students are continuously engaged, and we have 300 plus research articles and are consistently performing. We also focus on 360-degree student development, comprising of all the elements, starting from state-of-the-art laboratories to highly qualified faculty. We also annually organize international conference, Medcom, Springer affiliated, which is going to recently happen in October. We also organize actively international webinars, STTPs, workshops. Also, we take students to industrial visits, internships, workshops, and training. We provide value-added courses. also school outreach programs. We provide 100% placements and alumni interactions. The students are also, we focus on their overall development, personality development, and so they are engaged in extracurricular activities where they have the clubs activities, that is Anvita, and also technical fest, that is Tech Blitz. We also invite guest lectures from reputed and renowned personals from IITs, NITs, and industries. We also have NPTEL local chapter. We have ICE, IT, GL Bajaj student chapter, IEEE student chapter, our department journal, as well as newsletter. These are the best brains to mentor the bright minds of our EC department, the distinguished faculties of our department, the hardworking ones. These are the additional facilities, lab facilities based on to promote the research in the department, that is Cisco Networking Laboratory, then Technology Incubation and the Development Center, a center of excellences in biomedical image and signal processing, as well as SDR and MIMO systems, research and development lab, and CNC-based PCB routing. These are some of our glimpses of our student achievements, where one of our student, that is Kajal Srivastav, was selected amongst the only 5 projects from Pan India to showcase in front of Prime Minister Shri Narendra Modi and the Prime Minister of Israel, Mr. Benjamin Netanyahu. Also, our students actively participate in competitions like Anveshna, Delhi NCR, and are winning first, second prizes. So here there is this glimpse in Startup Awards, Atal Incubation Center and NXG Venture, Divisional Innovation Exhibition. The students are getting commendable. They are performing commendable in these platforms. They also participate in Technovation Hackathon. They have won first prize there. Then they are not only in national forums they are representing, they are also representing in global platforms, where we can see in Women Economic Forum they have participated. Also, recently the department also has signed MOU with ALTTC BSNL Ghaziabad. Then our students, this for this session, the highlight is we are always focused on providing 100% placement to the students. This time it was record breaking placement of 92% of EC department, where the highest package was of 18.2 lakhs and were placed in Cisco. And these are the top recruiters for EC 2021 batch. Our students also are innovative as well as have creative mindset, and they are establishing their own ventures and are successful entrepreneurs. This is a student who has just have a he's organized his company. We are organizing for our faculties also, as well as for students, webinars, not only for department, but also for our institute. So the topics are very much in trend and in demand. So these are some of the highlights which we have organized the events at the department. Then we also take our students to industrial visits to reputed industries like ST Microelectronics, Electronica, ALTTC, Uniconverge Technologies, Ministry of Electronics and Information Technology, so that we can make them industry ready. These are some of our notable alumni, where they are established in successful places. They are in Army, Air Force, Government of India, ISRO, Malaysia, and are now part of GLB family. So if you want to reach us, please contact us at this given email address. So now I would like to invite our HOD sir to please enlighten us with your kind words and welcome us today's guest.
Respected guest of the day, Dr. Brahmjit Singh sir, who is my guru, Charan Spars Pranam sir, all participants, respected director sir, all HODs, and dear faculty members. I am really blessed by God that today I am welcoming my own guru on this platform. I have no word, but I am very much thankful to you, sir, that you are coming and delivering some spur talks in my department, because today, whatever I am here, it is all due to your blessing, sir. And I'm very much thankful to you that you have joined on behalf of management, GL Bajaj, and EC department staffs and all members, faculty and students. I welcome at this platform, sir. I have no word to say because Guru is everything. I request director, sir, to say few words. I will not be able to speak anything, sir. Pranam, sir. Thank you, sir.
So first of all, good morning to all of you, and I welcome the chief guest of the day and the speaker of the session, Dr. Brahmjit Singh. And as rightly said, he is a guru, and I think he do not need any introduction. The topic which he is covering is very relevant: 5G wireless networks and adoption in India. And we are seeing that this adoption of 5G in the coming days will be available for the Indian citizens and the Indian mass. Now, as an electronics and communication engineering, because once we shift from the 4G, 5G, and 6G application, so it is very important for all the faculty members and the student to understand what is there in the 5G wireless networks and what are the issues, challenges which will be coming in front of us, so that we should prepare our student, prepare our faculty members according to the needs of the hour. So I think this is the need of the hour, as our mass total communication system will be shifting to 5G. And we have already seen that the government is taking a very hard step so that this networking, this communication channel should be available to the nearest corner of our country. And with the last 1.5, 2 years, we find that this is a technology which will be driving the future. With this thought, I am very hopeful that this sessions will be very, very interesting and very, very big learning for the student. And I have a pleasure for attending the session of Brahmjit sir previously. And I love his session. And he starts with a very, very basics and fundamental. That's the beauty of his lectures. With this, I once again welcome Professor Brahmjit Singh. And I thanks Department of Electronics and Communication Engineering for bringing these galaxies of people into one platform and discussing what are the issues in research and development which one has to focus as far as electronics and communication engineering. And I thanks Dr. Satin Sharma, all his colleagues, all the department fellow members who have organized this program. And I'm very hopeful that this will be very interesting and knowledgeable session for you. Thank you, sir, for your presence. Thank you, ma'am.
Thank you, sir.
Thank you, sir, for sharing such kind words. And now I will request Dr. Kirti ma'am to please introduce our speaker to the participants.
Sure, sure. Good evening, one and all. Myself, Dr. Kirti, and I am introducing the eminent speaker of the morning session, Dr. Brahmjit Singh, sir. He has received the Bachelor's in Engineering in Electronics Engineering from Malviya National Institute of Technology, Jaipur, Master's in Engineering in Electronics and Communication Engineering in the field of microwave and radar from the IIT Roorkee, and PhD from the GGS Indraprasth University, Delhi. He is serving as professor with ECE Department, National Institute of Technology, Kurukshetra. Presently, he is working as head Siemens Center of Excellence and Regional Coordinator, Regional Academic Center for Space, that is ISRO, at NIT Kurukshetra. He has been the Dean, Research and Consultancy and Chairman Department of ECE and Computer Engineering at NIT Kurukshetra. He has published more than 170 research articles in various international and national journals, conferences, and co-authored 4 book chapters. Under his supervision, 12 students have received their doctorates and 3 are working in the main theme. His current research interest includes microwave technologies, machine learning in wireless communication, and 5G and tactile internet. He is the recipient of the Best Faculty Award in 2019 conferred by the NIT Kurukshetra, and he will be the Best Teacher Paper Award. He get the Best Teacher Paper Award from the Institution of Engineers. He has been a regular reviewer for several IEEE journals and conferences and has been serving on the TPC of various international conferences. He is currently serving as the Vice Chair IEEE ComSoc Delhi Chapter, India. Welcome, sir.
Thank you. Namaskar to all the presentees. Congratulations on achieving very impactful and highly acclaimed milestones in the area of academics, research and innovation and outreach activities. Of course, the credit goes to the boss, Professor Rajiv Aggarwal.
No, the credit goes to the team, sir. Credit goes to the team.
And
I'm
yes,
only one of the member.
of course, the team is also equally need appreciation. Satyendra Sarmaji and Asthaji. So I record my appreciation the work you are doing in the Department of Electronics and Communication Engineering. And I do believe that under the visionary leadership of Professor Rajiv Aggarwal and the commitment and the responsibility undertaken by the team of Satyendra Sharma will take this department further to the next level. My best wishes. Before I start, I want to express my gratitude to Dr. Astha Sharma and Dr. Satyendra Sharma for giving me this opportunity to have the interaction with such a learned people who are attending this course. See, my talk is not new. Basically, nowadays, these 5G, 4G, 3G, they have become the buzzword of even common person who has never gone to technical institutions. Everybody talks about these generation cellular technologies. So I shall try to speak out how we can contribute to this technology. Otherwise, even far better than what I am going to present is available on the internet. So people are quite aware about these technologies, but let us see what are the challenges and what are the issues which we can contribute to as an academics, as a research scholar, or as an innovator. Okay. So with the permission of Dr. Astha, I bring in my presentation. Is it okay?
Yes, sir. Yes, sir. Sure, sir.
Is it visible?
Yes, sir. It's going to present. Yes, sir.
Okay. As Dr. Astha has already shared with the presentees, my talk is on 5G wireless networks and its adaptation in India. The point is, the contents which I have included in this talk is why 5G has created so much buzz around the world, including our country. Then what are the emerging applications? In fact, emerging applications are the major driving force to necessarily have 5G technology in the country. But if you want to realize this 5G, what are the requirements and what are the pending challenges, technical challenges where we can contribute and we can become a part of? Then I shall present few techniques which could be used to increase the capacity to the desired level of 5G. And then very interesting, and this topic is very near to my heart, adaptation of 5G technology in India. This is more of a policy matter. As far as our government is concerned, our society is concerned, what are the hiccups and what are the issues and what are the initiatives government has taken? I shall talk about that. Yes, the very first slide, I started with 5G wireless networks and why is it so important. I begin with very basic. Our professor has already told I commence with basics. Yes, I'm again starting with my basics that basic human activities. There are two basic human activities we do in our entire life. One is communication. हम बातचीत करते हैं एक दूसरे से, and there are several formats of these communication. Second is computation. Here the word computation do not relate it to the processing power, because I know networks are able to do the processing and they have enough computing power. Here the computation means economic activities. So these are the two broader activities we as a human do in our life. Communication is necessary for the survival of a human race. You will all agree with me. This 5G primarily refers to the cellular technology, which provides the necessary tool for communication. And here the communication is being repeated in a very broader term. Okay. On the other way, communication requirements are ever growing. See, we are not happy with voice communication now. We need a lot of things. We want to do telemedicine. We want to do surgery, remote surgery. There are so many things. We want to do automated vehicle. So the things are growing at a very fast rate. And as we are experiencing, the pace of growth is being witnessed in terms of the development of these technologies as well as the deployment, both. And there is a continuous evolution and revolution happening in the area of cellular technologies. 5G is the outcome of these efforts.
Sorry to interrupt you, sir. Please put your presentation in presentation mode, slide mode.
Okay.
Full
Okay.
slide.
Is it okay now?
No, not yet, sir.
Yes. Now?
No, sir.
I have shown it.
Actually, it is not in full screen mode. So.
I done it. Probably it is now in F5 mode.
Actually, we are still able to see your slides, other slides as well in the con.
Let me again try.
Yes, sir.
Some version issue is there, madam. It will not work. It will work in only this mode.
Okay, sir. Okay. So no issue, sir. Then please continue.
Will it work, madam?
Yes, sir. Your screen is visible. Yes, sir.
Okay. So this is what I have covered contents, why it is so important. I try to show that 5G refers to the cellular technology and which we expect it will meet our ever-growing demands of communication. Well, you all know that initially the mode of communications, the pigeons were used for communication purposes, and even still, I don't say that pigeons, the pigeons as a messenger, they have gone. No, still they are being used, but now they have become smart like this. Early methods of communication, sometimes it is interesting to go through the history. I have found somewhere that cave paintings were used to do the communication among the primitives, tribals, and it was related to create the alert among the natives about the wild animals. So they have cave paintings, and through these paintings they do the communication. The first recorded form of communication is available in 1800 and BC, and this recording of the communication is from China. The soldiers used the smoke signals to alert their comrades 500 miles away across the Great Wall of China. So this is one interesting example how communication methods evolved over time. And then electronics people know that Alexander Graham Bell invented telephone in 1877, and there are many things in between those. So I have skipped those, but the point I just want to show that the communication modes have evolved over time at a very fast pace. And as on date, 21st century, this is termed as information age, where everything has become digital. Like we never thought that I shall engage such classes through online mode. And I am missing the pleasure meeting with Dr. Rajiv Agrawalji and others. Otherwise, I would have gone to the campus and enjoyed a cup of tea with all the people and ambience of GL Bajaj. But anyhow, you see that now everything is digital. All education has based on the digital technologies online. So this is what has happened as a communication tool requirement in the area of communication. Digital development, because everything has become digital in nature. So let us see what are the various developments happening across the world. This data is already with you. We have the world population around 7.9 billion. This data corresponds to March 2021 date. And there are around 5.2 billion internet users across the country. Sorry, not country, across the globe, 65.6%. Now I just want to emphasize this point, growth rate. 1,332% growth rate has been observed over the years as far as internet penetration across the globe among the consumers is concerned. When we look at our country, we are the second largest internet population. Around 749 million people are using the internet. And this is important. 744 million are accessing the internet through mobile phone. This is where cellular technology comes into picture. 73% web traffic is coming from the mobile phone. This is how the continuous evolution and revolution in the cellular technology has been.
I think some internet issue on our speaker side. I request participants to bear with us for this small interruption. We will reach out to the speaker.
सर इज टेलिंग थोड़ा मिनट चला गया है, 1 मिनट में अभी दूसरा कनेक्ट हो रहा है, तुरंत कर रहे हैं.
Hello.
Ji sir, available sir, available.
Yes, sir.
I'm sorry, net is not reliable.
Definitely, sir. That's why we need 5G actually.
We need 5G. Okay, so I was trying to show the digital development across the globe and in our country. And I just wanted to show the importance of cellular technology and particularly 5G. Engagement of people with online networks is very high. Average time spent 47 minutes a day, 60% rise. This is basically related to a particular app. Then Facebook and so on. So I just wanted to show that people are immersive in bits and bytes. That is the point. And it may have some repercussions, positive or negative. That is another part of the debate. But I just want to show that it has become an integral part of our personal as well as professional lives. A brief history for the students is always inspiring and encouraging to go through the evolution history of cellular technology. You all will agree with me that in our country, the adaptation of cellular technology has been delayed by a decade or so. So whatever year I have written here, 1G came in 1980s, and in our country, it was delayed by 1 decade. Similarly, 2G, 3G, 4G, and 5G we shall talk about today. This is Cooper. Some of you might be knowing this person is having a Motorola phone in his hand, and this is the very first phone, which was analog in nature, and it has offered a channel bandwidth of 30 kilohertz, which is available to the mobile user. Then in 1990s, 2G came, and GSM has been the most successful and widely deployed standard of cellular technology. And here you see that the channel bandwidth provided to the user has increased from 30 kilohertz to 200 kilohertz, and the shape of this phone has a little bit improvised as compared to this bigger phone. Then 3G came in around 2000 in the world. UMTS is one illustrative example of a 3G standard. 5 megahertz was the channel bandwidth available. Then 4G, which we are supposedly using nowadays, but I shall share with you that even in our country as on date, there are a number of people who are using 2G. What to talk about 4G? LTE is the prominent standard of cellular as far as this technology is concerned. And here, this is an integer multiple. Depending upon the carrier aggregation, the channel bandwidth available to the user is 20 megahertz or its integer multiple, depending upon the technology. And then 5G, which we are talking about, this here, basically I written 2 gigas, 6 gigas and 100 gigas. They are the carriers. Here, the bandwidth available to the user will be an integer multiple of 200 megahertz. So if you look at these bands, channel bandwidth, you'll find that the user experience is bound to increase. And up to 4th G, it was the user experience. They want to have the telephony at a faster speed. That has become the major driver up to 4G. And because the faster phone can be had in terms of having higher bandwidth. So we are increasing the bandwidth and we are having a better phone speed up to 4G, but 5G has different motivation factors. Computing platforms, they were quite large. Then desktop were used, laptop, clouds came, and then it's a very complex cloud. Now, I want to tell you that cloud has been a part of 4G, but 5G, the cloud will play an important role. The networking platform, this is not so important, you already know. Defining applications, 1G, voice, web, and then you compare these 4G and 5G. Some of you may argue that even 4G can support some machine-to-machine applications, and they are supporting, but those are limited. The major focus of 5G is on machine-to-machine communication that we shall discuss. And then there are other applications like fax was possible. SMS was also a part of 2G. web came into being in 3G, 4G, Facebook, YouTube, and 5G, more or less, it is said that it is going to offer us intelligent communication. So this is how the brief history. Now, what we are using nowadays, we call it as a 4G standard. There are two versions, LTE and LTE-A. Long-term evolution, A stands for advanced, and LTE-U as well. Basically, this band is making a coexistence with Wi-Fi. So we call it as 5 gigahertz band. Otherwise, lower bands are 1.8 to 2.0 gigahertz. Data rate 100 Mbps. Latency, it is on the order of 10 millisecond, and the bandwidth available is 5 to 20 megahertz. But this can be extended up to 100 megahertz depending upon the carrier aggregation. Connectivity support in mobile environment up to 200 kilometer. So if we look at the applications of 4G, we find that yes, it is catering our need in terms of voice communication, data, video, web services, streaming, and interactive games as well. So the philosophy of these cellular technology developments was around delivery of contents. I mean, see, you know that when this email started, the purpose was to share some files from one computer to another computer. So you have contents, you want to deliver these contents from one point to another point. That has been the design philosophy till 4G. But 5G mandate is something different, and that difference makes it revolutionary in addition to evolutionary. There are some services which are termed as evolutionary, but the major mandate of 5G is in terms of revolutionary services. This is how these applications are causing the deficiency, or they are making the 4G as not adequate, like autonomous vehicles. Autonomous vehicles could not be supported by 4G. The reasons I shall discuss in terms of latency, real-time applications, intelligent transportation, drones. Drones has become almost, I think, drone technology is coming in all walks of our life. Robots, factory automation, healthcare and health monitoring, smart grids, metering, mission critical services, security and safety. This is not an exhaustive list, but an indicative list, and it shows that emerging applications are not merely delivery of contents. Their requirements are quite different from the communication requirements which were met by 4G standards. Let us say typical use cases. I taken two. One is a smart transportation system. In Mumbai, there was a data that per kilometer of road in Mumbai, there are around 1,500 vehicles. If the idea of connecting the vehicles, of course, vehicle to vehicle communication is appearing in a big way. 48% of the passenger cars, they have been embedded with connectivity, and it is expected that even nowadays the big cars, they are fully loaded with electronics and they are connected to internet. But the next application is that we want to connect the vehicles together. I mean, vehicle to vehicle communication is another area which is being developed in parallel with other technology. Then autonomous vehicles, if we want to run these vehicles without a driver, then they are going to use a huge amount of data, and processing of the data should happen in real time. This is a different use case which cannot be supported by 4G. Augmented reality, AR and VR, virtual reality, these are two more applications where the interactive reality is based on display environment, and we try to superimpose the information. So these kind of applications, they cannot be supported by 4G, and this is where 5G comes into picture, why 5G is necessary. If you want to experience these applications, we have to improvise the technology. See, when we look at these emerging applications and use cases, we find that the new communication requirements are looking for machine-to-machine communication, and there is no human intervention. First thing. Second thing, like if you take an autonomous vehicle, then in autonomous vehicle, it is some, you are basically replacing the driver. So you see what is coming in front of the vehicle, you collect the information about the surrounding environment, you process this information and take the decision in real time. So to make the things, so many things happen in real time, the latency should be in the order of 1 millisecond. We basically, it is somewhat similar to tactile sense, human tactile sense. So these two stringent requirements are the major driving factors for the development and deployment of 5G cellular technologies. Yes, I again want to compare that what are the limitations or cap of 4G LTE. Latency that is not adequate for industrial and mission critical applications. Reliability, like our net is not so reliable. 1/100 million packet loss is the limit. Which reliability we are looking for these mission critical applications. Capacity, I have given you the example of a vehicle to vehicle communication. We are going to have data hungry applications, and this much data cannot be handled by 4G networks. Power consumption and battery life, this is again very irritating as far as the consumer is concerned. We are trying to have complex modulation techniques, and more complex techniques are involved, faster is the draining of the battery. So these all are the limitations or cap on the 4G, which needs to be improved and make a new technology in terms of 5G. From definition point of view, 5G is the next IT infrastructure. And in order to support the future applications, we need to create a wireless communication network. I basically call it always as wireless communication network, which has huge capacity, very high reliability, and ultra low latency on the order of 1 millisecond or so. And this low latency on this order is the major challenge. And as I started with my speech, that in 5G, how academia can contribute. Latency reduction is a problem which can be addressed right from the BTech students up to the PhD in higher level. There are some simple techniques where we can study what are the various parameters which make the latency in cellular networks. What are the problems and how we can address those. So this is a very interesting problem. There are a number of papers available where electronics and even computer and IT department take on these smaller projects, how latency problem of which is basically a bottleneck to realize the applications which I have pointed out, latency 1 millisecond. So you must try simple projects on latency reduction in wireless communication networks. This is how we can realize the potential of 5G. Yes, driving factors. So just to summarize, automation and real-time applications. And here I just want to focus on this, that now the design philosophy of next gen 5G is based on machine to machine and ultra low latency. So it is not just a content delivery, it is a different kind of experience of the application. It is not mere high data rate, but support to novel application and services. So the design considerations of 5G cellular technologies are not same as those were pursued up till 5G. This is how 5G is different from the remaining generations of networks. See, this is a very common question. that how 5G is different from 4G or the previous generations of cellular networks. Here we have to point out that the design philosophy is entirely different. We are looking for a different user experience. It is not just a fast phone. Otherwise, in simple words, we assume that if a phone is fast, then it becomes a higher generation. Take away points just for the academic purpose, M2M communication and extremely low latency. This is what we want to achieve. It is not high data rate, but it is a revolution. So rest of the generations are termed as evolutions. But in case of 5G, we call it as revolution because of the different mandate, because of the different design philosophy. 5G is, of course, an enabler to bring the change in the way we live, we socialize, we work, we do the business, we do the manufacturing. Yes, this slide is meant for students. What are the requirements which we are looking for in 5G? First is scale in terms of connectivity. Because now IoT is coming and everything is becoming digital, so the scale of connectivity onto the internet is increasing like anything. You want to connect everything. Billions and billions number of devices are being put onto the internet. So scale is becoming enormous. Now you look here, when scale is so big, what kind of architecture can support such number of devices? This is an open problem. It's an interesting problem. A kind of architecture which can support this scale. Then of course speed, data rate, because we as a consumer are always interested in having a faster internet service. Then latency, I told that if you want to realize the automated vehicle type of applications, you want to do the automatic robo processing, or you want to do the tactile kind of applications, then latency has to be reduced. So latency reduction is another requirement. Of course, security, though I am not covering the security in this talk, but security is again a very, very major issue in wireless networks. And you will see that Pegasus has stopped the proceedings of our parliament for so many days. So security has become a major issue. Anyways, that sometime other point of time. Scale of connectivity. This is the first requirement of 5G architecture. As I just told, everything being connected onto the internet. And it is not internet of things, rather it has become internet of everything. 7 trillion wireless devices. This figure may rise now. Traffic generation per square kilometer around 750 Gbps. So we are moving to a world which is super duper connected. 1 million connections per square kilometer. So we are going to have massive number of sensors and actuators which are distributed in the geographical area, which is going to become a part of a ecosystem of 5G. Second is, so first was the scale, the second is speed. Downlink speed, we expect that 5G will provide 20 Gbps. And if you look at 1 million connected devices per square kilometer and you need the downlink capacity of 20 Gbps for per user kind of. So we want faster speed, carrier bandwidth 100 megahertz, spectral efficiency this. So if you compare the above things, vision is that no, we are not happy with 20 Gbps even. The vision is to increase this downlink capacity up to 50 Gbps in macro coverage and 100 Gbps at micro level coverage. So these are very challenging issues. I'm again repeating the architecture of 5G. What kind of backhaul links would be which can support such speed and capacity. Latency is a third point, third requirement of 5G. Ecosystem. As I told you that our even BTech students can take up some simulation problems. Latency is composed of these parameters like over the air transmission delay. So you have to compute these. Queuing delay, processing, computing delay, retransmission delay if needed. All these parameters make the latency. And for a general term, it's just response time. Like you do the ping for computer networking, and you see that if the response comes within so many milliseconds, the network is there, otherwise there is no net. So latency primarily is related to the response time. And from user's experience, lower is the latency, better is the real-time experience. For audio signal, 80 millisecond is the round trip latency requirement, and we are comfortable to have the real-time communication of audio. 4G provides end-to-end response time on the order of 50 to 70 millisecond. Over the air, it is 10 milliseconds. So you electronics people now can give the focus on this. See, in 4G LTE, the total end-to-end latency extends up to 70 millisecond. But the propagation, which I have written somewhere, over the air transmission delay is only 10 millisecond. Over the air may not be addressed, but the rest of this time could be addressed because it is happening in queuing delay. It is happening in processing delay. It is happening at MAC layer. So if you can design something at MAC layer, you can reduce the latency. This is a very interesting problem, and I hope some of the students and faculty will take up the latency reduction. Tactile internet is basically tactile internet is supposedly coming in 6G. So here is something like if I touch something here, then the same feeling should happen at the farther end. This is touch screen enabled applications. In no time, if it looks like I'm sitting at a remote place, if I press a button here, the action happens at the same time at the remote station. So tactile internet is primarily making a lot of difference in remote surgery. But all these things require very low latency, 1 millisecond, maximum 4 millisecond. Ultra low latency communication is a research challenge. It's a very important challenge and open challenge. Security, you all know, because everything is a part of internet. So the surface area is quite ubiquitous and pervasive. So there could be some weak links, and the hackers or the eavesdroppers or jammers, they can take the advantage of this weak link, and they can enter into your network from any point, and they can play havoc. So security is, as far as 5G and scale of connectivity is concerned, it is going to become a major issue. These are various dimensions of security. Yes, I just want to give some ideas how to enhance the capacity enhancement of a 5G networks, which we are expected to cater to the requirements of emerging applications. Wireless traffic growth, you'll agree, is expected to increase by 3 order of magnitudes, 1,000 times. Now, the question is how to increase the capacity to handle this immense traffic being generated. This is the channel capacity theorem. This capacity theorem is in relation to cellular systems. Otherwise, C is equal to B log to 1 plus S by N. That is a common channel capacity theorem. This theorem has been improvised to consider the cellular system. So this is very important. You see, R is the transmission rate, C is the channel capacity, M is the spatial multiplexing. You know that nowadays we are having spatial multiple streams between transmit and receive. So this M refers to the number of streams between base station and the user equipments. S, desired signal strength, I, interference, and N is the noise. W, of course, is the base station signal bandwidth, and N is again very important, load factor. I mean, how many users are sharing the resources of a single base station. So this is the design theorem. We use this theorem to design a 5G networks, how to enhance the capacity. Let us see how to use this theorem. First is, in this theorem, the first is bandwidth. So if we have more bandwidth, we can increase the channel capacity, and hence we can have a higher data rate. But the issue is that in wireless communication, bandwidth is always limited. Anyhow, efforts are on to have more bandwidth like millimeter waves. So either we can procure additional frequency spectrum to increase this W and hence more transmission rate. And this shows almost linear increase. This is not practical, this is theoretical, that almost there is a linear increase in data capacity with respect to bandwidth. Second point, here we have taken the load factor. I mean, how many users are using the resources of a single base station. So cell splitting, this is not new, a very old technique where cell splitting could be used to improve this load factor. The idea is that if there is a heavy load in a particular cell, then you can reduce the cell size. It will be having a different antenna and its transmit power will reduce. So the basic idea of cell splitting is same, that you can have better frequency reuse. There is a formula MKS. If you repeat the same set of channels, you can have larger system capacity. But anyhow, this is one technique which you can look for, not new. Now, interference minimization, you all know that cellular networks are not noise limited, they are interference limited. If anyhow you can reduce the interference, you can always increase the capacity, and you can use multiple antennas as well. This is something important, network densification, and this is the technology which is being used in 5G for capacity enhancement. Spatial densification, if we can increase M by N, then of course through densification we can increase the capacity. Spatial aggregation, we can realize a spectral aggregation. I mean, you have more bandwidth, you can realize more transmission rate, or you can have larger frequency spectrum. Millimeter waves are being explored 30 to 300 gigahertz. So we can have more number of antennas per node. We can have more number of specialist teams. When specialist teams are more, we call it as densification, and then we can increase the system capacity. We can have a more number of base stations in a given geographical area. So more number of base stations in a given area will certainly improve load factor, but it has its own advantage and disadvantage. Like if it's a congested area, you need it some place to erect the tower. Anyways, but technically we can increase the load factor by having more number of base stations. Backhaul is another issue. Yes, this is something what the faculty members and students should do. A design criteria through air throughput. I just want to show one figure. You please look at this figure. Here, the design criteria for cellular technology comes through this figure. This is a 3D figure, and on x-axis I have taken the spectrum efficiency. On y-axis I have taken the cell density, number of base stations per unit area, and then on this z-axis we have taken the bandwidth. That is, if we can have more bandwidth, we can increase the capacity. If the techniques like modulation, coding and all those, they are spectrally efficient, we can increase the capacity. And if the cell density is higher, we can increase the capacity. So from design point of view, basically this comes through an area, and we call it as area throughput. If we can increase this area, we assume that throughput, which is the representation of a capacity, is enhanced. Yes, this is the formula, that capacity in general terms, it reflects on data rate, but simultaneously it also reflects on the number of users. So it is not merely that fast data rate. If there are only 2 users, they can have, like on a highway, if there are a few vehicles, they can run at a very fast speed. But if the number of vehicles are more, then speed will be hindered. And so the capacity comes in both data rate as well as number of users. And we can have more capacity if we can squeeze more information in a given bandwidth. So area throughput has been defined as a critical parameter as far as the capacity enhancement design techniques are concerned. and it is measured in terms of bits per second per kilometer square per cell. And the simple formula is throughput is given as B into D into SE. D is the bandwidth in hertz. You increase the bandwidth, throughput will increase. You increase the average cell density per square kilometer D, area throughput will be more, capacity will be more. And spectrum efficiency per cell, which is measured in terms of bits per second per hour per cell, then of course the area throughput will increase. So we can pick up either of these. Like bandwidth, we are trying to explore the millimeter waves. Those are just increasing this B. Then cell density, we are having smaller cells. Then spectrum efficiency, there are so many things happening, massive MIMO, this and that, which are going to increase the spectrum efficiency to increase the area throughput. So this is very interesting, how to improve the area throughput, additional bandwidth, which I just talked about, and base station on those. Yes. Challenges in providing additional bandwidth. See, frequency spectrum, as we know, in wireless communication is always limited because there are various services being offered in this frequency band. In general, for wireless communication networks, the frequency spectrum available is up to 6 gigahertz, and overall bandwidth available is around 1 gigahertz only. So in order to increase the capacity, which I shown in the previous slide, that we want to increase the capacity by 1000 times. So if you want to increase this bandwidth, we require the bandwidth of 1 terahertz to have this capacity enhancement. And we cannot have 1 terahertz. 1 terahertz could be only in terms of optical communication. So that is impractical. There is an opportunity here in terms of millimeter waves. And you know that millimeter waves extends from 30 gigahertz to 300 gigahertz. But again, this is interesting. BTech, MTech, and PhD students can do some project. The problem is very short range. Here, the range is in the communication range at millimeter waves is around 150 to 200 meter. Then additional base stations we can have, of course, in 4G. The cell area is reduced, so we can have more base stations. But there are some issues, like if you have more number of base stations, handover will be an issue. There will be frequent handovers. Anyhow, this is a technique, and it has become a part and parcel of 4G techniques, reducing the cell radius and having more number of base stations, because capacity has become important. Spectrum efficiency. The efforts are on to have new modulation techniques and new multiplexing techniques. So that leads to spectrum efficiency. Meshing MIMO, again, this is the most promising technique to improve spectrum efficiency in future cellular networks. And spectrum efficiency can also be increased by having greater value of SNR. But you know that if you want to have greater SNR, this is not possible. Increasing the power will also increase the interference. So this is neutralized, and this is, I think this is never explored to increase the capacity. Power scaling approach is not of much value as far as spectrum efficiency improvement is concerned. And this is the typical value of spectrum efficiency in LTE, 1 to 5 bits per second per hour. This is typical value. So you look at, I have given few possible solutions to have the capacity improvement. The wireless capacity we want 1 million fold in 50 years. So if we achieve this capacity through wider spectrum or additional spectrum, we need 15 times. If we go for MAC and modulation, then we can have the gain of 5 times. If we can design some MAC modules, MAC protocols, if we can design some new modulation techniques, then of course we can improve the gain factor in capacity will be 5 times. Network densification and reduced cell size 2700 times. Here I just want to show that if you want to achieve the gain in the capacity, you can have 15 times by having additional spectrum. You can have 5 times by having smart coding techniques, or you can have network, you can have 2700 times capacity improvement by employing network densification and reduce cell size. So if you compare these, this is the most promising technique to achieve the desired capacity enhancement. And the people are working towards network densification, the small cell deployment. Small cell deployment is the technology which is being used, deployed across the world in 5G. Yes, additional spectrum, of course, millimeter waves is a big, good area, research area. And this has been implemented in experimental setups as well, because we are looking for 20 Gbps minimum data download speed. So up to 6 gigahertz, we don't have enough bandwidth. So what we are looking for, that go for millimeter waves. These are the various bands which are available for cellular communication. And if we go for millimeter waves, we find that it provides huge bandwidth. In previous slide, I have shown that bandwidth available for cellular is 1 gigahertz. Here, if we go for millimeter waves, the bandwidth is 150 gigahertz. And carrier bandwidth increases up to 500 megahertz. So we can have a very high capacity network at high data rate if we employ millimeter waves. Just one simple result, the issues with millimeter waves. So it is very interesting and encouraging to have such larger bandwidth. But the problem here is that the communication range is quite limited. Very high path loss happens. So even you can try this MATLAB program and see that the communication range is very, very limited in case of millimeter wave employment. Characteristics of millimeter waves, these links are inherently directional, so we can do some AI/ML in the beam training. Millimeter waves, they face blockage. If there is a human being or there is a furniture in the room, then they interrupt the communication, and they make the even human mobility in a room, they make the millimeter wavelengths intermittent. So these are the very challenging issues if you use the millimeter waves. No linear distortion of power amplifiers due to high ERP and use bandwidth. So you can look for if we can address these issues in the development of technology. Otherwise, millimeter waves are very interesting and very powerful in terms of additional bandwidth. Propagation modeling, there are a large number of papers. Professor Agarwal and even Satyendra Sharma ji, they have done a lot of work in this area. Channel modeling papers are available in literature, but India specific channel models, I hardly find few. There are some papers in WPC and transactions, but our environment is something different from other countries. So we can look for what kind of channel models for millimeter waves could be designed. Sensitivity to blockage, this I have already told that yes, it is an issue, and application of millimeter waves in 5G. So we are going for massive densification, I mean smaller cells, and looking for frequency band 28 gigahertz to 38 gigahertz. Cell size is around 200 meter, and someone has shown this 4.75 Gbps data rate at 10 meter. This is an experimental data in some lab. I don't remember the name of the lab, but I want to show that millimeter waves have been put into 5G infrastructure, and they are at a 10 meter distance. The distance is an issue. So like the range of Bluetooth. So it is providing a high data rate 4.75. So further developments are happening. A backhaul is again an issue, because everything is connected to the internet. So every sensor, every node is creating huge data. So what kind of backhaul should be there between base stations, between core and access networks? So for the architecture of 5G, this is again an interesting point. E-band, I shall talk again. Small cell densification, it will provide 2700 times gain, no doubt. But having smaller cells will have its own issues like handover rate and intercell interference. So, but anyhow, the practical implementation is like this, that 5G is not a single technology, is an umbrella technology which is covering almost all kinds of technologies under its umbrella. MIMO, massive MIMO, again, this has become a part of 5G infrastructure. We are putting large number of antenna at base stations, and they have co-channel users at a time. So basically we are taking the advantage of the channel itself, that many random characteristics asymptotically turn into some deterministic ones. So with the help of massive MIMO, we can increase the capacity by an order of magnitude. But the issue here is in pilot contamination or pilot orthogonality. So this issue can be looked into at academic level. Full duplex operation is another part, is another technology which is happening in 5G. For human communication, human conversation, when I speak, I listen at the same time in the same frequency band. But this is not exactly or precisely happen in cellular networks. TDD, we use all cellular technologies are based on time division duplex and or frequency division duplex. There are some issues if you use full duplex operation in communication, and that is self-interference. So in-band full duplex operation is feasible, but we need to innovate the techniques where self-interference could be reduced. There are some PhD work on this where the self-interference has been reduced to a large extent, and we can simply double the spectrum efficiency, but it is not so easy as I'm stating. SI cancellation is a technical issue. However, this is again an interesting problem for projects. D2D communication, this is coming again in big way in 5G deployments. The idea is that if there is a group of nodes and they are in close proximity, then they can bypass the basic infrastructure and two devices can communicate directly with each other. But again, I would like to tell you that it's not so easy, because ultimately you need a resource, and resources are handled by cellular. So how to take the resources from the cellular and offer those resources to the user, this is a big challenge. So later, anyway, D2D communication has already been implemented in part, and you can look for how the problem here is associated with resource allocation to the users. Yes, let us come to the launch of 5G. You all know that there have been field trials for so long across the world, and even there are some countries even in South Asia like Korea, Japan and China, they have already deployed 5G to some extent, and that is the outcome of these field trials. NTT Docomo, Mitsubishi, they have done a lot of experimental trials, and they have come up with some results like US Fox Sports Streaming. They have done this streaming of sports activities at 1.6 Gbps. Samsung, even in a stationary environment, has shown that the data using 5G technology can be transferred at a rate of 7.5 Gbps. You can imagine that if the data is happening at 25 Gbps or even 7.5 Gbps, what kind of experience the user will have. This seems to be very interesting. These are some more industry developments which are causing. Let us come to the very important topic, India's preparedness for 5G technology. What is happening in our country to 5G? You see that India is the largest market of telecom equipment. Huge AT&T, Ericsson, all these companies are growing in the Indian market. We are procuring telecom equipments like anything, and we are the second largest user base. Just hello. गुड मॉर्निंग, गुड मॉर्निंग। हाँ, मेरा ना 12 बजे तक मेरा लेक्चर है, उसके बाद आता हूँ, ठीक है? ओके ओके। सो let us give attention to these aspects which I want to share with you. Wireless telephone subscription as on 30th June 2021, I taken this data from TRI report, 1.18 billion. This report was published on 23rd August. And we project that by 2025, there will be 88 million 5G connections. This is just a projection. This is the scenario what we offer to the players of 5G technology. Okay, but on the other hand, we have launched a number of programs in our country, and Digital India is one of the highly ambitious project of India. Vision of a Digital India is digitally empowered society and knowledge economy, but its success entirely depends on the access and reach of wireless communication network to the last person. If Digital India has to be successful, then the communication facility needs to be extended to the last person. And for this, India is geographically is a vast country, and we have so many diversities. It's not all urban. It's even a large population lives in rural areas where infrastructure is not good. We need a robust and all pervasive digital infrastructure, and it is agreed by one and all that yes, 5G technologies could be a possible solution to make Digital India successful. Let us see again. BharatNet, some of you might be aware, Government of India has started this program, and they have laid down 3 lakh kilometer fiber to rural parts. That's okay, but they have one handset in Panchayat Bhavan, and they assume that the entire village is connected onto. That is not enough. Now, you see that we are engaging the classes, and some of my students are coming from rural areas. And in the rural areas, network connectivity is not good. So frequently and regularly, they face the disadvantage in terms of this online teaching and learning. Education, they are a disadvantaged section of the society. So the point is that Digital India initiative could be leveraged on 5G infrastructure. See, I don't say that we are not good in as far as the technology development is concerned. Just for reminding you, Sir J.C. Bose, it's very interesting to read his biography. He has given the idea of millimeter waves. In addition to that, plants have feelings. And Sir J.C. Bose's method was so perfect that no one had yet been able to repeat his experiment. Even his work was appreciated by Lord Rayleigh and William Crookes. Now, see, we have such a legacy with us as far as the technology development is concerned. What is the status in terms of 5G technology? Deployment, we are ready. We are the biggest market, second largest market. But what is the status of development? Initiatives. What are the various initiatives our government has taken to adopt 5G technology? Government has formed and instituted a 5G high-level forum under the coordination of DOT, and they have developed a vision for 5G ecosystem. And in this 5G ecosystem, there was a consortium of academic institutions with some industries, particularly ISC, IIT Madras, IIT Bombay, and IIT Hyderabad. They are the major stakeholders in this project. And they have come up with some spectrum policy, regulatory processes, education awareness promotion programs, and they are supposed to develop some use cases. They have, you might be knowing that IIT Madras has developed a 5G test bed. And this forum is also is coming with certain roadmap for rolling out the 5G services in India. But something has happened. This is encouraging for all of us that this consortium, IITs and some industry and DOT, they have given an Indian version of 5G. We call it as 5G I, and this particularly developed by IIT Hyderabad and IIT Madras. And the inventors claim that this solution of Indian version of 5G is very cost effective. It is spectrally efficient, and it causes less wastage of spectrum. See, frequency planning is a kind of spectrum utilization. So they have also focused on the spectrum utilization. So they claim, this group claims that they have less wastage of spectrum. Now, I don't know how many of you are knowing that the standards in cellular technologies, they are ratified and approved by third generation partnership projects. Now, in our country, we have tried to develop our own procedure. But in this case, there has to be a harmonization, because see, when I say I have a network, it is not a stand-alone network. I have to be a network which is globally pervasive. So if my protocol does not harmonize with the protocol, let us say in Japan or US, then there will be some interoperability issues. Okay, so this is a challenge that we have done very good as far as this group is concerned. 5G I, just take pride in that we have developed a solution. But the challenge is, this is another, that the challenge is that we have sent these 5G I solutions to ITU for the evaluation. And to date, as far as my knowledge is concerned, I don't know what is the status of the evaluation of 5G I at ITU level. But we hope that something good will happen, and that this 5G I, at least to some extent, will be accepted at the global level. The idea of this protocol is that this is good. This please remember this LMLC. This LMLC is a protocol which has been customized. I'm again repeating, which has been customized for low mobility and large cell. Now you see, low mobility and large cell is applicable to rural area, because in rural area it is supposed that the movement of the people or the movement of vehicles is not happening at a rocket speed. There are low mobility regions, and the population is sparse. So we need to customize the 5G technology for our rural areas, and this is what has been done by this consortium, LMLC. But the issue is the harmonization of third generation partnership project. So you just try to think that how we can harmonize, or how we can sync our solution with the global solution. This is very challenging issue, and we are looking forward with finger crossed. We have done some field trials by telecom companies and OEMs. We have drawn some insights about the performance, but there are a number of technical challenges of deploying this technology. Ericsson, in collaboration with Bharti Airtel and Reliance Jio, they have done some more field trials. Yes, there are a few more issues in our country as far as 5G deployment is concerned. We read in newspapers that Reliance Jio has made other private players almost bleeding. If we want to deploy these 5G networks, it requires huge investment, huge investment. And I read somewhere that 92,000 crore is the debt on telcos. So if they are already debt ridden, how they will invest in 5G infrastructure? You just think over what will happen. And you may not agree, but to a large extent, probably a Reliance geo pricing strategy is giving this trouble to other private players. I'm not against any player, whether it is Reliance or Idea or Vodafone, but somehow there is an order from Supreme Court. They are required to deposit huge money with the government, and they don't have money, so they are just bleeding. Except Reliance Jio, and having one player, private, that also private player in the area of telecommunication will be a disaster. This is what personally I believe. There should be a level playing field for n number of private players for these kind of services. So this is the first challenge towards commercial rollout of 5G infrastructure in our country, and that is financial position of telcos. This is again interesting. See, in a large part of our country, still we are using 2G. We are not using 3G and 4G. In fact, 2G was successful, 3G was not successful to that extent, and then 4G came. But when we evaluate the mobile internet speed vis-a-vis other countries, we find that we as a country stand at 109th place out of 124 countries. In India, the average speed is 9.12 Mbps. On the other hand, the global average is 23.54 Mbps. So this shows that somehow we are not able to take the advantage, to leverage the potential of 5G still. It is still in nascent stage. What are the regions? What are the problems? What are the issues? Okay, even you'll find that feature phone, still there are a large population of our country is using feature phones. So what to talk about the advanced services? So these we have to look into. Use cases. See, we have a habit that what is happening in Japan and what is happening in US and UK, we try to copy it. But the fact is that our conditions, our working, our culture, everything is different. And hence, when we talk about the deployment of 5G technology, we don't have the same kind of application requirements as Japan has or as South Korea has. Okay, we have some basic requirements. We want to connect every village through a Digital India program. So this is a specific requirement. We want to have some basic services. We don't want to have internet gaming or streaming gaming. So the point is, it's a very important aspect. You just think over that we need to develop India specific use cases for the employment, for the implementation of this technology. Let us not copy it that I want to see the web series through internet or through mobile phone, or I want to play an interactive game. So there is a small set of people who use these services. Larger population needs basic services. They are interested in what is the status of rain and all those. Second point, we are very price sensitive. We look for इसकी कीमत कितनी है. This is very important aspect, and this is in our DNA. I don't say there are some high-fi people, they don't care about money, who go to big molds. But as a common man, we are very sensitive. We look for what is the price, and economies of the scale. We always look for that. Yes, let us wait, and the prices will come down, and then I'll buy this technology. As I told, that feature phone they are good enough for 2G communication. So 4G is not pan India. So 2G communication is enough for a larger part of the country still. So 4G capacity is good enough to cater the existing requirements, including that of IoT. Antenna structures, yes. There are like few questions that what we need to change if we want to switch from 4G to 5G. So you see that we are exploring the use of millimeter waves. For millimeter waves, we need a different kind of antenna structures, and we need to make some changes in the handset as well. So having this infrastructure is quite expensive. And who will do it is BSNL and MTNL. BSNL and MTNL are already, they are looking for how to bail out. They look forward to the government that they should give some package so that they can come out, they can survive. So government sector is almost done. There is a little hope that they will compete with these people, other people, particularly Reliance. They don't have money to spend to create this infrastructure. Early and timely steps, but if we want to grow, like we are talking about Atmanirbhar Bharat. In case of Atmanirbhar Bharat, it depends upon the smart manufacturing. And smart manufacturing is entirely dependent on the technology. That is Industry 4.0. Large extent it is based on IIoT, Industrial Internet of Things. And Industrial Internet of Things are going to use a huge portion of 5G technology. So we have to adopt 5G, but how to support this system in terms of the investment. We need a very strong and robust backhaul infrastructure. This is what 4,71,000 towers. This is just an order. We need 1 lakh more towers at least. 2.78 billion US dollar we are looking for. So huge investment is required as far as adoption is concerned. This is another issue. You should examine this case. I told you that billions and billions number of devices will be connected, and every node is creating some data. So if you look at the backhaul has to be enormously capacititious. It has to support huge data. At global level, E band and V bands. V band is at 60 gigahertz. E band is at 70 to 80 gigahertz. These bands have been opened at the global level to support backhaul. But in our country, we have still to introduce these bands. I don't know what is the status, whether we can opt for these two bands, but if we want to support the backhaul on wireless, we need these bands. Otherwise, we have the optical fiber cables, and in optical fiber cables, there is hardly any cap, any limit as far as bandwidth is concerned. It is enormous. Even we are not able to harness the entire band. That is another issue. But optical fiber cable has their own issues, and we are talking about wireless networks. So wireless networks has some advantages in terms of V and E bands, but we have to take that decision, and this is a policy matter. Regulatory reforms. This is again interesting. TRAI, Telecom Regulatory Authority of India, they are involved. It's a major recommending authority, and they publish some papers and they decide some, they frame policies and all those. They have tried to do the spectrum auction, 3.5 gigahertz and 28 gigahertz. This is one band. 3.5 to 3.7 gigas, and they provide a channel band of 175 megas only. This was tried by this try, and they have set this base price in this band 492 crore per megahertz. Now, I read in some paper, even you must be aware that people are saying that is these telecom companies are stating that this base price is the highest in the world. And probably that's the reason that this auction process is not complete as yet. So if we don't have the spectrum auction till date, then there is hardly any likelihood that the 5G services will be available in our country in near future. And another part, you just look, 175 megas is the only spectrum. This 175 megas is not enough to provide the kind of services we have envisaged in 5G. So this is again a big bottleneck, and I think government must act upon these aspects if we want to come up with the technology, if we want to remain in sync with the technological development across the world. Yes, I'm just nearing my talk. Opportunities for our country. See, I am very fond of wireless services, but our selection should be careful. 5G is coming with cellular technology, and it is giving evolutionary services in terms of faster phone, because I already given that it's a 20 Gbps downlink speed is possible. So the phones will become very fast. On the other hand, there are revolutionary services which shall be offered by 5G, like mobile edge computing, augmented and virtual reality. I give you one example of mobile edge computing. See, Internet of Things is again becoming an integral part of industry, or not for industry, even agriculture and healthcare. So in IoT structures, because the sensors don't have enough storage requirements, and they don't have enough energy, they don't have processing power. So what we are looking for, that we should have a mobile edge computing. And for mobile edge computing, new services need to be developed. Over here again, we need 5G kind of infrastructure. And then augment AR and VR, of course, they need 5G infrastructure. So the result is that 5G cellular technology has immense potential for business opportunities as well as social services. And it is very interesting to note that 5G is not simply a voice service or some communication service. It is going to become a virtual infrastructure. We have to keep this in mind. 5G is providing a virtual infrastructure in parallel with physical infrastructure. Whether it is transport, whether it is health, whether it is manufacturing. If 5G is so important that it is complementing the physical infrastructure, then we cannot avoid it for long. We cannot delay the implementation of 5G. Enormous opportunities in terms of economics, in terms of social fabrics, as far as 5G is concerned. So my takeaway point is that we have to have 5G in place at the earliest possible. However, our country is very typical. There was a case in Supreme Court by some Bollywood heroine, I don't remember name. The 5G is bad. I don't know what they know about cellular technology, but anyways, this is a free country. Anybody can speak anything. However, my point is that 5G technology is a must if you want to grow, and if you want to move with in comparison with other countries, and if you want to have Atmanirbhar Bharat dream to be realized. Conclusion: yes, 5G technology is an enabler for economic and societal growth. It is a powerful tool to realize the vision of true digital society through Digital India initiative. And I believe it is a major catalyst for digital revolution with both capacity and reach. This is very important for our country. That's why I'm telling again and again that we have to customize the use cases, reaching capability in the remote areas. There was an intention that commercial rollout will happen in 2020, but it is 2021. Now we expect that it will be roll out in 2022. I don't know, but we look forward and we are very positive and optimistic that 5G services, at least in part, will become a reality soon in the time to come in our country. Let us contribute as a student or as a faculty, as an academia, towards the development of this future inspiring technology. That's all from my side. Thank you so much.
Thank you, sir. Thank you for this session. I hope this has certainly benefited from breadth of knowledge and depth of experience of yours to the participants. Now we are open to question and answers session.
Yes, please.
So I request the participants, if you have any questions, feel free to put in the chat box or can unmute themselves. Meanwhile, I would encourage our department to please interact. And if you have any queries, please feel free to ask.
Good morning, sir. Mera ek question. I have one. Sir, if we will increase the number of base station in the area, if we increase the number of base station in the area, I think
Hello?
if I
Hello?
increase the Ji sir. Are you getting, sir?
Ji.
If I increase the base station number of base station in the area, same base station may be creating interference with the other base station, then capacity may be decreased.
Yes, interference is a major issue.
Yes.
But the basic design criteria is that you limit the transmit power. If you limit the transmit power so that it does not spill over the boundary, we can decrease the interference. So yes, interference will be there. And it is not interference, it is the complexity also.
Okay.
So
overlapping of signal we have to reduce.
Yes, overlapping. And see, Sharmaji, in engineering, there is no perfect solution.
Yes.
No perfect solution. There is always a trade-off. So you have to have a very poor SNR to support the services. And that is why we are improving the technologies which can minimize the impact of interference and noise. Interference will be there, noise will be there. How to make our system rugged against these enemies? So you are right, but there is no perfect solution.
Thank you, sir. Thank you, sir.
Yeah, sir, I have one question.
Ji, sir.
So let's say I'm really very interested in whatever you have discussed about the millimeter wave in 5G.
Ji.
Right. My question is, as we already know that the range of this millimeter wave will be very limited to not more than 200 to 300 meters. And then you have rightly said, let's say the what we say it as a obstruction, human to human and other aspect of this will be there. So is there any papers which has worked on the real aspect of this? How, let us say if we designing any of the system wherein you are rightly said, let's say we do not have any such cases where we talk in terms of Indian scenario, because once this is a millimeter wave, then the constructions and other part will also play an important role. What type of a material you are using, what type of furniture you are using. Is such type of a studies there where we can think of, let's say having like for architecture, they design something. Why we not come up with some case studies where we say, let's say, look, if you are looking for some, let's say really good communication, so you should design your offices, you should design this with the optimized solutions. I don't know to see any such studies there.
No,
let's say, for example, every aspect will be.
Yes. You are absolutely right, sir. Very interesting question. We must carry out such studies, and I don't have much data on such studies. We have to do it. We have to do it. These are the problems which are generated by millimeter waves. Right. But until and unless we carry out this, we cannot come up with some model.
Second is, sir, let's say, because then it is again will be issue, because now in case of what we say it as a fading and other aspect of it, we are using a mathematical model which is more inclined towards the two probabilistic. One is a log normal and another is a Rayleigh. Now, if we see this, maybe this may we have new model where
Yes.
these two model will not be very accurate. So once we go to the millimeter wave, what are the aspect of this? I think Deepthi Ranjan Patnaik, you are doing something in case of this millimeter wave. Am I right?
Yes.
Yeah. What is your view?
Yes. See, sir, we have tried to do some simulation models, taking the meteorological data like raindrops. Raindrops have impact, and then some obstacle material characteristics to put into the models, and then see
Achha.
how does have what is the effect on the performance. So we have tried, but I think if we can have some experimental kind of setup, that will be a very good boost to the implementation in Indian context. In Indian context, we don't have much modeling of millimeter waves in our country.
So ultimately, sir, I think in millimeter wave, it is not a what we said as a indoor wave propagation rather than outdoor propagation. It will be more related to indoor wave propagation.
Yes, yes, you are absolutely right, sir. It will be very good for indoor because it will provide huge data, download speed. And I think if we can customize our, though it is very difficult to control the movement of people, but at least orientation could be managed and we can have better downlink and uploading speed in millimeter waves. We must explore,
Right, sir.
we must explore the
Thank you.
millimeter waves.
Thank you, sir. Thank you.
Dipti sir, I think so. You also want to add something? So your mic is muted. Not audible.
If anybody have another question, I think there are some questions which is coming.
There are questions in the chat box.
Yeah, we should.
Yes, from Mr. Ganesh Kagupati, he is asking, I keep hearing that 5G will require millions of small cells. Why is that?
5G will require millions of small cells wise. This is again, we want to increase the capacity 1,000 times, 1,000 times. And I have given a formula B into D into SE. So it is not only network densification, it could be other techniques as well. If you have more bandwidth through millimeter waves, we can have a trade-off with number of base stations. But there are some experimental performance gains. If we have a network densification, we can have 2,700 times performance gain. Okay. So in addition to having more bandwidth, it is better to explore network densification. That's why we are going towards having more and number of base stations.
Okay. Thank you, sir. Another question from the same participant is that does 5G require new spectrum?
I have already told, yes, if you want to have more data rate, you want to include more services, you need more spectrum. And here, the spectrum I told, we started with 30 kilohertz, GSM 200 kilohertz, then we went to 5 megahertz, then 20 megahertz, then now we have reached, we envisage in 5G as 500 megahertz. So we need more spectrum. Yes, we do need more spectrum. Regarding what is the basis for moving from generation to generation, say I told there are two kinds of things. One is evolution. Evolution means मुझे चाहिए faster phone. दूसरा है we need revolutionary. I want to have like Internet of Things kind on factory floor, where you have thousands and thousands sensors on a factory floor. Every sensor is collecting the data. We want to send it to some cloud or some processing unit. How to do it? How to carry out? We have new services, revolutionary services to support. So we need a different architecture, and that is 5G.
Yes, sir. Thank you so much
No,
for
it is
throwing
not.
that.
Is millimeter wave? No, though Professor Rajiv Agrawal has already told that millimeter waves are very useful for indoor, but you can use millimeter waves for a broader area as well. It's not only femtocell. Up to 150 to 200 meter, they work well.
So I one minute, sir. There is some disturbance. Please, I request participants to mute themselves if you don't have any questions to ask. Thank you. So, sir, I hope this is all which we have got the queries. If you have any other queries, participants, then you can drop a mail to us. We can reach out to the speaker. And personally, I saw that in your the slides there were design criteria where you emphasize on area throughput, and you told about those three axes: cell density, bandwidth, and the spectrum efficiency. So, what will be the design criteria for 6G when whether the more dimensions will be coming, or means what will be? Can you throw some light on that aspect?
The idea of 6G, they basically focus on intelligent communication. There is some intelligence embedded in 5G, but they say no, it's not enough. 6G will be entirely based on intelligent communication. जैसे हम डिसीजन लेते हैं, मशीनें अपने आप डिसीजन लेंगी, अपने आप कम्युनिकेशन करेंगी. So that is the mandate of 6G, intelligent communication. And this is not good.
It is more towards machine-to-machine communication, augmented type of a what we say it as environment, where you have a machine and the human which will be interacting.
Yes. Is any radiation problem? Sanjay ji, there are two issues. According to IEEE literature, which I have studied to the best of my knowledge, radiation does not cause some cancer kind of things. They say that yes, it has a heating issue. That the if you give more exposure, then the tissues will warm up. But there is no conclusive evidence showing that it leads to cancer kind of things. Yes, it does heating of the tissues, the skin tissues, and we should avoid continuous exposure.
Yes, very true, sir. And that actress which you were saying, that was Juhi Chawla, and her case was she had filed.
We cannot ignore the technology if we want to survive in this world.
Yes, sir. So now I would like to propose a vote of thanks to conclude today's session. I deem it a great honor to propose a vote of thanks to all those who have helped us in making this FDP a memorable experience, today's session especially. And I, Dr. Asta Sharma, on behalf of ECE department, extends a very hearty vote of thanks to Dr. Dr. Brahmjit Singh, our chief guest of the day, for gracing today's session. Thank you, sir, for taking out valuable time from your busy schedule and sharing such insightful and thought-provoking session. I would also like to express a profound gratitude to our director, sir, that is Dr. Rajiv Agrawal, sir, for his kind presence in this webinar and being active throughout the session. I would like to thank HOD, sir, Dr. Satyendra Sharma, for his continuous moral support and guidance. I would also like to thank our Department of Electronics and Communications for encouraging me and our team, and as well as taking the responsibility so good. So that is a very great team which we have here at department. And also finally the wonderful participants for your unwavering attention throughout the session. Thank you so much for your cooperation. And hope we will be having another session at 2:30. So please join us using the same link which we have mailed you. Thank you all.
Thank you so much, and special thanks to Professor Rajiv Agrawal.
Sir, my pleasure,
Always
sir.
nice to interact with you.
No, sir, it's always my pleasure, and then I have learned so many things from you, and especially the aspect which you have touched. I'm really, really grateful for that, because you have also touched the social aspect and the economical aspect, which nobody is understanding, that how Geo is playing with our country. That's a major aspect which we are not understanding. If it is a monopoly, what will happen to the customer? That's the issue which nobody is understanding. I think that aspect you have touched. That's the biggest, I think, what we say it as information which you have shared with us.
And a short announcement, someone has asked for attendance link. The attendance links will be shared in the afternoon session. So we request participants to be active in both the sessions, morning as well as the evening. Thank you.
Thank you, sir. Thank you, sir.
Thanks. Bye.
Thank you, sir.
Take care.